is the last talk for this track. And I can imagine that you start to get tired after a long day. So I actually prepared a bedtime story. The story about the brave little tailor. It's a story about a tailor that kills 7 flies with one flow of his hand. And he's so impressed by his own skills that he makes a belt reading 7 at one blow. And everybody believes that he's talking about killing 7 men. Long story short, he manages to trick and defeat various creatures and becomes king at the end. My name is Judith Kahrer. I'm not a tailor, neither a king, but a product manager at Curity. And instead of killing 7 at one blow, I settle for addressing 2 API security risks with one scheme. So today I want to show you how to use OAuth to address and mitigate the top of the top API security risks, the most critical API security risks that the Open Worldwide Application Security Project, OWASP, identified. Those are number 1, Broken Object Level Authorization, and number 2, Broken Authentication. And I start bottom up. So broken authentication occurs when there's an error in the implementation of authentication. Authentication is the process of verifying if someone is who they claim they are. If you mess up with authentication, you enable attackers to eventually compromise an authentication token or credentials and impersonate a user. And if you impersonate a user, you can do all the tasks that the user is entitled to. Read data, manipulate, update data, or delete data. And you can imagine if an attacker manages to take over an account with high privileges, the potential damage will be severe. So how do you prevent that? Well, first of all, do authenticate. Not only on the perimeter, but also between API calls inside that network. And this approach is called Zero Trust. Do not reinvent the wheel, but use standards. Implement multi-factor authentication and consent mechanisms to reduce the impact of stolen authentication tokens and credentials, and prevent your authentication process against brute force attacks. How can OAuth help? Well, OAuth is a standard. OAuth is not authentication, though. OAuth is about delegation. However, that is exactly what you want for your APIs, because delegation means that you don't authenticate the user directly, but access gets delegated. So I want to show you briefly how OAuth works. So first, the client requests an authorization grant from the user. It then exchanges this authorization grant for an access token at the authorization server, and then it uses the access token in its calls to the API to get access to the precious data. When you look closer to the actual implementation of this abstract flow, you realize that the client is not getting the authorization code directly from the user, but via the authorization server. And since the authorization server, or the story goes kind of like this. So the client asks the user to seek the authorization server. So the user approaches the authorization server and says, well, I want you to deliver a message to the client with my grant. And the authorization server answers, I can do that under one condition. I want you to solve a quest first. But that's kind of an artistic freedom. What usually happens is that the authorization server challenges the user to authenticate. And since the authorization server is a dedicated security component, it can support all sorts of authentication methods. Username and password, federated authentication with protocols like OpenID and SAML, passwordless authentication using, for example, WebAuthn. It can combine different methods, add additional factors like SMS, email, one-time tokens. It can even adapt the authentication process and make it dynamic. For example, it can only enforce multiple factors if it thinks it's suitable. It can protect authentication processes with anti-brute force mechanisms like account lockout, cooldowns. It can offer services like secure password recovery and account recovery. So in other words, the authorization server can offer secure authentication and account management. If we now recall, what we need to prevent broken authentication, we realized that by introducing OAuth and the authorization server, we can already check 3 items in the list, 3 at one blow. So the only thing that the API that remains for the API is the requirement on authenticating every request. And to make things even easier and simpler for the API, you can utilize an API gateway to enforce the zero trust. So before any request reaches the API gateway can make sure that only authenticated requests, only requests with a valid token pass. And what is more is that it can ensure that no matter the structure and format of the incoming token, it can always ensure that it always forwards a JOT to the API. So the only thing that the API has to do when it comes to preventing broken authentication is to properly validate this JOT. And this means checking the validity time. Is the token still valid? Does it come from a trusted issuer? Is it intended for the API? Is the API including the audience? Check the scope, the signature. And when it comes to this validating the signature, prefer asymmetric algorithms and have a list of predefined approved algorithms. JOTs have a structure. They have a header, payload, and signature. And attackers can trick JOT validation algorithms in accepting crafted JOTs by manipulating JOT headers. So you shouldn't rely on the JOT headers alone for signature validation, but you should define which algorithms you support. So you should have a list of approved algorithms. What may sound quite like a burden to implement can be implemented with easy code, as shown in this pseudocode. So you just define some options. You define which algorithms you support, or as I said before, the trusted issuer, the expected audience, the scope, and you take the options together with the JOT and the verification key and call the verification function. And since OAuth is a standard, JOTs are standard, there are plenty of libraries that help you with that. And after successful validation, you can continue with the authorization, which brings us to the second risk, Broken Object Level Authorization. This means, or this occurs when users get unauthorized access to objects. And this can happen when object IDs get manipulated when they're sent with a request. For example, object IDs can be part of the URL. Broken object level authorization means also that there are failures, flaws in the access control mechanisms, which can lead to data disclosure, manipulation, data loss, and in worst case, account takeover. And we already know what that means. How do you prevent broken object level authorization? Well, OWASP says that you should use random and predictable values for object identifiers. And this makes it for sure harder or impossible for attackers to guess valid object IDs, but it doesn't solve the underlying problem. It doesn't prevent or fix the flaws in the authentication mechanisms. So to fix or prevent that, you should define policies. So there should be rules that define who is allowed to do what under which circumstances. And you should implement the authorization based on those policies. Validate the permissions on every request. That's similar to what I've said before on the authentication. So on every request, authenticate and authorize. Don't forget to test authorization to avoid adding or introducing new flaws at a later stage. Do not deploy anything that doesn't pass the tests, but I think that's self-evident to point out. When you implement authorization, keep the following cheat sheet in mind. Apply the principle of least privileges. Only assign as much privileges as are required for the current task, not less and not more. If you assign less, users won't be able to do what they are supposed to do. If you assign too much, they will do what they are not supposed to do. If you're unsure, deny by default. And to avoid risks like the broken object level authorization, implement attribute-based access control. And this is where the access token becomes very handy, because the access token carries data. As I mentioned before, it can carry standard claims like the issuer, the audience, but also other claims like the subject, the scope, or business-specific claims like the customer ID. You should use the scope for coarse-grained access control. Assume you have an order API and you define the scopes order read and order write. Then an access token with the scope order read may be accepted for GET requests on the orders endpoint, but not on other endpoints or APIs, or even for other HTTP words on the same endpoint. You can then use business-related claims, business-specific claims, for the fine-grained attribute-based access controls. So you can use a customer ID and check if the reference customer is allowed to access the given object. And how do you know that? Because you have policies that define that. So you can use the claims from the access token to implement the attribute-based access controls and prevent broken object authorization. So what do you need? You need to validate permissions on every request, and you need attribute-based access controls. What do you need to prevent and address the top API security risks? You have to authenticate order requests. You have to validate permissions on every request. You have to implement secure authentication, and you have to implement attribute-based access control. On a personal note, regarding implement secure authentication, get rid of passwords. How do you do that? Well, you use OAuth, because with OAuth you can outsource authentication and delegate access with access tokens. You can utilize an API gateway to enforce zero trust and perform the coarse-grained access control to offload the APIs. And then you can then use the claims in the access token for the attribute-based access control. So with OAuth, you can mitigate two of the top API security risks with one blow and get a scalable security solution for your APIs. Thank you.